the diagnostic imaging at Pisa University Hospital and Associate Professor of Radiology of the University of Pisa. Please, Dr. Brady, if you can join the lecture and give your lecture. Thank you.
Thank you very much, Valerie. After that exciting series of presentations about the potential applications for AI, I'm going to tone things down a little bit with followed by many years in university and medical school, and quite a number of years again in postgraduate training after medical school. And ultimately, that leads us into practice. And there are many influences on all of us during that period of time: family, cultural influences, natural empathy, interaction with real-life humans. And we hope that all of these lead to ethical practice when we actually are let loose upon the population. It's a little bit different with AI. AI lacks all of this. It comes straight in at the practice element. And we can't be quite sure that the robot doctor will bring all the good baggage of empathy and family and education with him when he starts becoming a practitioner. So it's our responsibility to ensure that those ethics are imbued in AI when it is utilized on humans. And it's for this reason that many institutions and bodies have published papers in recent years on this very issue of ethics in artificial intelligence with respect to radiology and many other applications. This particular paper is a multi-society one presently in preparation, involving the ESR and a number of other societies in North America and elsewhere, and a few of us in the room are involved in it, and it's out for public consultation at the moment. I particularly like this one. It's from the European Data Protection Supervisor. I like it because it's in pictorial format, and being radiologists, we like pictures. Most of these papers say much the same thing. They consider the various principles that are important to the practice of radiology utilizing AI: patient safety, avoidance of bias, explainability and transparency, privacy and protection of data, liability for decisions made and how decisions are made in terms of diagnosis and treatment, and ultimately governance and application. Go a little bit further back, there have been a number of efforts to apply or define laws of robust day. And again, there is a commonality across all of these sets of principles. Fundamentally, do no harm, including being free of bias and deception. Respect human rights and freedoms, including patient dignity and privacy, while promoting patient well-being. And be transparent and dependable, while ensuring that humans are ultimately responsible and accountable for what happens to patients. If you read papers about the ethics of artificial intelligence in radiology, they will commonly break down the topic into three areas: data, algorithms, and practice. And this is very helpful and very valid, but there's a lot of crossovers. So if we break it down further into the specific issues that are relevant, many of them apply to two or three of these groups. So what I'm going to do for the next few minutes is go through a number of these issues without necessarily tying them into one of the three groups explicitly. Let's start with data ownership. In the United States, the entity performing the imaging owns the data. Patients have a legal right to a copy of their imaging data, and in many hospitals, the general consent to treatment signed by a patient when they come to the hospital also covers permission to use data retrospectively for research. There's no additional consent required. The situation in Canada is marginally different, but very similar. It's very different in the EU. The GDPR states that patients own and control their own sensitive, personal and/or identifiable data, medical or non-medical, and patients' explicit consent is required for sharing or reuse of that data, and that consent can be withdrawn. In addition, over and above that, the sites where the imaging is performed can be subject to ownership and copyright regulation and may have some elements of ownership over data. So to use data within the EU for AI applications, for example, may require consent from imaging facilities and from patients, which complicates the issue somewhat. Furthermore, if you break it down, we heard earlier about data in K-space. Equally in CT, what the machine actually acquires is raw data, which is generally not interpretable by the human brain or human eye. This is converted into pixel data, which is what we look at, and that bodies or different people. The pixel data might be owned by the owner of the imaging machine, for example. The labels might be owned by the radiologist. So if data is to be utilized, we have to address the issue of who actually owns it. This is particularly important if the data is used to build a highly profitable AI product. Who has the rights? I don't have the answer to this. A lot of this talk will be asking questions rather than giving answers. Imagine a scenario where a hospital sells the exclusive rights to imaging data to a company, which hopes to build a valuable AI product. Well, that's fine, but if patients also retain their right of access, can they sell their individual data to a rival company? Or can they refuse to share their individual data for commercial development, but allow it be used for non-profit research? Well, that rather complicates the hospital's arrangement. This isn't theoretical. In 2015, the Royal Free NHS Trust in London entered into an arrangement with Google DeepMind Health to give Google access to over 1.5 million individual personal identifiable patient records for no charge. What this was all about was developing a tool to identify acute kidney injury early. But the NHS was severely criticised for this. It was said that they were seduced by the magic of the algorithm company and didn't realise they were the ones with the really important thing, the data set. Privacy and data protection and data ownership are allied issues. Is it necessary, if patient data is to be utilised to train AI algorithms, that each patient would sign a data use agreement with any third-party entity contributing to their health record? And we have to ask, is it necessary that if their data is to be utilised to train successive iterations of the algorithm, must they give consent for each new version of the algorithm? Well, I don't know the answer to this, but data use agreements probably need to explicitly specify what involved parties can and can't do with the data set and what they must do to dispose of the data once the agreement expires. Data use agreements should be updated regularly to reflect new uses, and this raises the question of whether, if new versions of the software are being trialled, must the agreement be revisited? Must the user save or archive a version of the patient's data for each version of the software that it has been used to train? All of these are complex issues. It's probably true to say that exclusive use data use agreements are contrary to the common good, because they may remove a significant amount of patient imaging data information from general use for development of other AI tools or other research possibilities. Data privacy. We're all used to de-identifying or anonymizing imaging studies for teaching purposes, for exam purposes, for research. But de-identification isn't really anonymization, because in general, patients can probably be re-identified through things like DICOM tags. Anonymization, true anonymization, is a further process that irreversibly breaks the link to the original identification. But even true anonymization may not be entirely secure. If, for example, you're dealing with a 3D data set of a CT of head and neck, if that's put through 3D recons, facial recognition software might be able to identify the patient. There may be identifying information on radiographs, personal jewellery, serial numbers on implanted devices. It's been said that entities facile with manipulating massive data can likely re-identify just about any radiology exam. Well, this is a problem if patient data is to be utilised for training commercial products. In addition to that, social media companies are adept at identifying patients' software or individual software usage and online search histories. Smartphone usage in a particular location to a particular imaging study, and thereby identify the patient to whom the images refer. These are issues that must be addressed in terms of data privacy. biases. We've heard a little bit of talk about biases previously. The key one is selection bias. If the training data set doesn't represent the population accurately, then there may be underrepresentation of certain subsets of the population in the training data set, and that can have knock-on effects in terms of the applicability of the algorithm to the general population. In addition, data sets may overrepresent positive or interesting exams. Remember, most examinations are normal. Well, perhaps not in cross-sectional imaging, but in other modalities certainly so. So if there is what's known as a negative set bias, the algorithm may not be trained to recognize normal when it sees normal. Issues arise around ground truth labeling. If I fall and hurt my wrist and go into the emergency department and have a plain x-ray of my wrist performed and it's perfectly normal, is the ground truth normal? Well, if I come back 2 weeks later because I'm still in pain and have another x-ray performed and this one shows a subtle scaphoid fracture, does the ground truth for my first examination be scaphoid fracture present, even if the human eye can't see it? It's not clear. These are slightly tricky issues. The ethical duty, above all else, is to minimize bias. We must be transparent about how ground truth is determined for every data set, and we must train models with data sets that truly represent the populations they're going to be used upon. Automation bias is another bias that can creep in. We like gadgets. We like algorithms and computers, and there is a tendency for humans to favor machine-generated decisions, regardless of what contrary data we may be faced with. So this may lead to an over-reliance on computers or blind agreement with the output of algorithms. Again, this isn't theoretical. This is a study from 2004 over a 6-month period in a major US hospital which used computerized ECG interpretation. 35% of patients were misdiagnosed as having atrial fibrillation. And what's more, the physicians failed to correct the misdiagnosis in 24% of them, which led to treatment changes and complications. It's possible to rely excessively on automation. We have to take patient preferences into account. A study in 2017 showed that 65% of American adults were uncomfortable delegating the task of making a medical diagnosis to a computer with AI. But patient preferences aren't necessarily always coherent. Let's look at what the public want out of autonomous vehicles. People approve of utilitarian autonomous vehicles, which would sacrifice the passengers for the greater good if faced with the choice of running over pedestrians or sacrificing the occupants, and would like others to buy them. This is known as the trolley problem. But the public would prefer themselves to travel in cars that would protect the passenger at all costs. There's a lack of coherence in this thinking. Above all else, algorithms must be safe and secure throughout their operational lifetime, and that requires a certain amount of transparency. We need to know what's going on in the algorithm, and if harm is caused, we need to know why harm has been caused. You're not going to trust your life to one of these things if you don't know what's leading to its making its decisions. So what we're talking about here is value alignment. AI tries to optimize what it's built to do, and that's usually a mathematical algorithm or a mathematical output. We have to ensure that it's optimized for the benefit of patients, real live humans. AI performs particularly well with classification tasks, and I think a lot of the talks we've heard earlier would emphasize this, but it struggles with abstract concepts like fairness and equality. These are difficult things to teach an algorithm to do. Fair use of or access to AI is not intrinsic to the mathematics behind most algorithms. If, as a radiologist, we're faced with the diagnostic dilemma, a human radiologist intrinsically understands the cost-benefit analysis of undercalling or overcalling. If we're reporting chest x-rays, we understand that if we undercall free gas underneath the hemidiaphragm, the consequences for the patient may be grave. So many radiologists are likely to slightly overcall that. That's a tough bit of thinking to program into an algorithm. I mean, in terms of image annotation, the cost of failure in terms of whether an image recognizes a dog or a cat or a car isn't very great, but the cost of getting medical diagnosis wrong is very much higher. So humans perhaps overcall sometimes, bearing this in mind. How do you program that into the algorithm? What we're talking about here is the black box difficulty, the stuff that's going on inside algorithms that's difficult for us to understand. Ideally, these algorithms and AI applications should be interpretable. We should be able to understand the workings of the model. We should be able to explain them in understandable terms. As far as possible, they should be transparent so that outside viewers can see what's going on within them. But that in itself is a difficulty, because that, if it's overly transparent, the model might become subject to malicious attacks, or might reveal proprietary intellectual property, which wouldn't be very welcome to commercial companies developing these algorithms. So all of this is an undefined and difficult area. The GDPR further complicates it, because it states that automated decision-making systems that have a significant impact on a person aren't permitted without that person's consent, and the individual has a right to an explanation of how the automated decision was arrived at and its consequences. That implies some transparency and explainability, which may not be easy to achieve. The Institute of Electronic and Electrical Engineers has gone so far as to say that autonomous and intelligent systems should always be subordinate to human judgment and control. There should be ethical oversight by end users, those responsible for developing AI tools, practice managers and payers, and patients should accept this. Ultimately, the main challenge is to anticipate what can go wrong and how these rapidly evolving systems could be abused. But even saying that practice managers or payers should have some oversight carries problems as well, because AI systems could be used by practice managers for outcomes that wouldn't necessarily be of benefit to patients. They could be tweaked to ensure that users are guided to actions that meet quality metric requirements or attract more patients or increase profit, regardless of whether that's for patients' ultimate benefit or not. Resource inequality is another issue to be addressed. AI needs resources, data, technology, skills, computer power. Proprietary AI applications may cost money, may cost a lot of money, and capabilities to apply AI in radiology will not be evenly distributed. There will be disparities across different economic groups or different countries. And we have to ensure, as far as possible, that there are not biases against resource-poor communities in terms of the population data sets used to train and develop the algorithms, and against group-level subsets of individuals in terms of application of these. Liberal eugenics is a term that's been applied to the use by a subset of the population of special access to resources to gain an advantage. For example, using an expensive radiology AI screening tool. As far as possible, we have an ethical responsibility to ensure that tools are available to everybody. Liability has been touched upon by a previous speaker. If something goes wrong, who's responsible? Is it the radiologist, or the institution that purchased the algorithm, or the developer, or the AI company? I don't know the answer. Nobody does yet. It shouldn't be forgotten that radiologists are often involved in commercial entities and may have some interest in ensuring that those commercial entities are successful. There are possible remedies for this, of course: public disclosure of conflicts, institutional oversight, perhaps divestment or recusal from purchasing decisions may be necessary in some circumstances. We shouldn't assume that radiologists always wear the white hat and do everything properly either. There are fears that AI will displace workers. Radiologists have a vested interest in not being displaced, so it's quite possible that we might engage in behaviours designed to ensure we continue to have jobs, regardless of whether they're of benefit to patients or not, and we might design tools to ensure this. Obviously, this isn't necessarily the right thing to happen. So the best way to ensure AI tools are used ethically is to make sure we understand the moral risks we run when developing and using them. This very good paper from the Canadian Association of Radiologists, published last year, says that high-level medical imaging data science is neither child's play nor impossible. Good machine learning is powerful, helpful, and valuable, but bad or unethical machine learning is dangerous. Caregivers and governing bodies should be wary of grandiose claims originating from people who have a profit motive in trying to sell you an AI tool. Algorithms, above all else, are amoral. At their core, they are built to optimize some function. It's up to us to override the bias and imbue them with human values. Radiologists are learning about ethical AI at the same time as we're developing AI in radiology and using it. We need to make sure we keep up with the ethics. We need to develop codes of ethics and practice for AI. These need to be updated continually. They must focus on transparency, patient protection, and vigorous control of data versions and uses. and they must be continually monitored for unintended consequences with corrective action where necessary. We must not outsource ethical thinking to technology companies. It is our responsibility as physicians to imbue AI tools with these ethics. And to quote Stephen Hawking's last published book, published last year, our future is a race between the growing power of our technology and the wisdom with which we use it. Thank you.
Thank you very much, Dr. Brady, for your extremely interesting lecture. You have pointed out very critical and important issues. So now, Professor Neri, the good news is the paper has just come up, I think today or the day, and it's published online and it's available on Insight.